From 5G networks to aerospace systems, from artificial intelligence to quantum technologies, from behind the scenes of innovations to real-world applications. Welcome to Innovations Unplugged, the Rohde Schwarz technology podcast. Let's start with a fact. The world we live in depends on wireless connectivity. 5G mobile communication enables crystal clear video and real-time collaboration with your colleague, even in a crowded urban coffee shop. You use GPS to navigate, and it can even reroute you around a sudden road closure or accident. Remote controls steer your kids' toys and drones alike. Air traffic control helps planes don't crash.
Welcome to the world of the radio spectrum, the invisible highway of modern life. Today we dive into how Rohde Schwarz technology quietly safeguards our society, from ensuring seamless mobile networks to countering drones. We meet two Rohde Schwarz experts who are redefining security in a connected world. Hello, my name is Markus Haller.
And I'm Inga Müller-Siedentop, happy to host this show. And I'm even more than happy to welcome Ronny Stiffel as our guest today, a senior system engineer at Rohde Schwarz. Ronny is a spectrum monitoring and counter-drone tech expert who's helped make the radio frequency spectrum more secure, kind of everywhere, even at Formula One races. Ronny, thank you so much for joining us.
Hello, happy to be here.
When we talk about radio spectrum, what do we mean by that? And why should every one of us care about it?
So imagine the radio spectrum as an invisible highway around us or even in the sky. You have wireless communications, mobile phones, Wi-Fi routers, computers, daily appliances in your kitchen, in your home, your TV, and more or less every device that communicates without any attached cable. And so all those devices are working in the radio frequency spectrum, and so the spectrum is full and it gets more crowded compared to the last decades. Nowadays, every device has a kind of wireless connection. So the frequency band gets more and more crowded, and we have to make sure that everybody follows the rules, and so that we have a seamless connection and a good connection for all of us.
Just to make this clear, you mentioned that it is super important that the spectrum, the radio frequency spectrum, is regulated. It's just a simple kind of fact that is necessary to make the devices communicate, right? So they have the same spectrum to use and the same frequency bands, for example.
Absolutely right what you are saying. We need those regulations in the spectrum because we have a lot of certain types of devices, and authorities have to make sure that we do not have a chaos in the spectrum with all those IoT devices, Bluetooth devices, and so on.
All right, so that means radio spectrum, it concerns every wireless device. They are transmitting data on certain frequencies, and these frequency bands are crowded. To give us a better idea about it, I know you have a very nice example, including a washing machine next to an airport.
A few years ago, Rohde Schwarz was asked by the Amsterdam Schiphol airport where they had an issue. Every Saturday in the time between 9 o'clock in the morning and 2 o'clock in the afternoon, there were interferences in their systems, and they didn't have any clue where they come from. And this was for the airport a dangerous situation because the air traffic was affected by these interferences.
When we talk about interferences at airports, it could be critical or risky because there are so much other signals that should not be interfered, right?
Exactly. An airport has a lot of wireless communications between not only the airplanes in the sky and the ground and the air traffic control, the airport itself, but also on the ground there are certain wireless communication systems and flight control systems. And so this is then strict controlled, and every interference leads to risky situations or could lead to risky situations. So they have to make sure that there are no interference at all. So the colleagues arrived in Amsterdam, and on a certain time, on a Saturday between 9 and 2 o'clock in the afternoon, they saw the interferences on the Rohde Schwarz devices. So they figured out the signal comes from a flat area, quite a big building with a lot of flats. And then they figured out, okay, this is this certain building and this should be this flat where the interference signal comes from. And then together with the police and the authorities, they ring at the door and surprised a man who was washing his clothes at this time. And the reason for
Can you imagine the surprise?
For the interference was a defective washing machine. So the electric motor in the washing machine was broken a little bit and created there a very strong electric interference. And this interference then led to problems on the Amsterdam Schiphol airport.
I think a very nice example. It shows every one of us is just one broken washing machine away from getting in touch with the radio spectrum, right? To find this interference by accident, as it was in the example with the airport, to find them, this is the discipline of spectrum monitoring 4. Ronny, can you explain us a little bit, how does this work?
So we have a wide range of very sensitive antennas, specially designed and created for spectrum monitoring to cover the spectrum in a designated frequency bandwidth. The antennas listening into the spectrum, and then on those antennas are tuners connected or receivers connected. We have different types of receivers, and those receivers are able to analyze the signal. Not only the signal type, but also the power of the signal and the direction of the signal.
And since we also would like to talk about countering drones, Ronny, and now you have to give us the connection between spectrum monitoring and counter drones. How do they match?
Countering drones or detecting drones in the RF spectrum is kind of a part in the spectrum monitoring area. So countering drones evolved from spectrum monitoring, because when I want to look after a drone, I look with our devices and software on a certain frequency band for a specific profile of the drone.
The radio frequency technology is far from new. The radio frequency landscape has grown, and yes, it has increasingly become complex over time.
So we see this is what is happening in general in spectrum monitoring. The highways getting more and more dense. What's happening with the drones, Ronny?
So the drones is a phenomenon that we have since roughly 10-15 years. At the beginning it was a toy, it was more or less a hobby to build a drone and also to fly a drone, and then people figured out, we can put cameras onto a drone and take nice pictures, and then this technology evolved very quickly, very fast, and then 10 years ago we saw the first issues with those drones, that not everybody just taking pictures with the drones, but using it as a kind of weapon. Not only that you put an explosive or an ordnance below a drone in a conflict area, but also imagine a prison. Where the people working at the prison had then huge problems, because small drones were used to smuggle drugs and weapons in those prisons.
I see.
But when we focus on spectrum monitoring again, radio frequency steered drones may endanger the spectrum itself, because it's using it to steer it, just to control it.
Exactly, and so this is the reason we have since several years the Rohde Schwarz Adrones product suite. Can see not only that there is a drone, but also the direction, and if we have more than one of our systems, we can also pinpoint with mathematical triangulation the position of the drone, and not only the position of the drone, but also the position of the drone operator.
To better understand the scale, let's take a closer look at this Formula One story. The scenario at such an event illustrates how these challenges manifest when large crowds and advanced technology converge in one location, in one place. Can you take us with you?
Yes, so the request to support the Formula One circuit in Zandvoort came in 2021, early 2021. So this event was quite huge for the Netherlands and especially for the Dutch police, because it was the first Formula One race after 33 years in the Netherlands. And also given that Max Verstappen is a hero in the Netherlands, there were a lot of things to prepare. And also, the Dutch police and the Formula One was aware at this time that not only spectrum monitoring is important on such an event, but also to check for drones. Point of protection was the helicopter flight path. You can imagine when there's a Formula One race, you have the TV helicopter flying quite low. And also you have the medical emergency helicopter, and we had then to make sure, together with the Dutch police, that no drone was flying in this area to endanger those helicopters and the races. The police had two of those their own drones in the sky to have a kind of crowd control to see 85,000 guests arriving. The whole city was crowded, and also this area. And so the police used their own drones to make sure that everything goes to plan. But also we detect a lot of drones not allowed to fly there.
Okay.
Mostly tourists taking just pictures from the racetrack, but they were not aware that they may endanger the helicopter flight path, but also the race itself. So we were in close communication with the police to detect them, and then the police went out to those pilots and confiscated their drones for the time of this race.
Okay, again, when we have a closer look at this kind of circus, what is happening there, we do have crowds who just have their mobiles with them, right? So they want to be connected, which might be a bit complicated when there are so many people at one location. We do have the drone situation, as you just explained, that the other drones, like private drones, should not interfere the path of a helicopter. Again, back to spectrum, should also be not in the spectrum, right? In the radio frequency spectrum.
Exactly, because especially on this dense area, every frequency that's used, not only by the Formula One itself, but also by the race teams, is strictly regulated. So a lot of spectrum monitoring devices were placed around the circuit itself. A lot of those antennas and receiving devices, especially in the paddock and where the teams have their tracks and material, just to make sure that also those teams are using only the frequencies that they are allowed to use, that there is no illegal communication between teams and certain other people. So then the next factor was that you have a lot of mobile phones, mobile devices from the guests that are arriving. This is also then a challenge for us, that our receivers and antennas are able to detect interferences or drones in this dense spectrum. And this was a challenging area, but it was good to see that our devices were working perfectly.
To see what is happening there at Formula One, this is also happening in the big scale in the countries. You have much more radio frequency used. You need much more regulation. You need much more and very sophisticated equipment to check for all of this.
What are the options when you are out there at Formula One or anywhere else and you detect a drone? What are the options? What can you do?
So the challenge in countering drones and detecting drones is, first of all, you must see the drone. So if it's a radio frequency operated drone and not an autonomous one, with our F detector we can see the drone. Depending on the scenario, we are also able to block these drones so that they stop. That depends on the authority. Normally we are not allowed to jam or to block a drone in a public area.
So when we talk about the evolution of drone technology, One term you already mentioned is when drones become more and more autonomous. But then, as far as I get it, we don't have any kind of RF signal steering it.
Exactly. So those completely autonomous drones, or also called dark drones, they do not have any RF signal that they emit. They are pre-programmed, and normally you can fly them starting with the computer and without a remote control, and they follow programmed GPS waypoints. And if they have to fly in a GPS-denied area, for example, in a war zone, they are connected, for example, to a fiber optics cable. This is very thin but very long, and it gets the control signals and directly then over those fiber cables. And also the third option to be a dark drone is to have a kind of imaging database and a geographical database built into the drone, and then with the optical sensors, for example high resolution cameras built into the drone, they follow the terrain and compare it with the database built into the drone to fly completely autonomous. And this is quite dangerous because we do not get any signal of them. So the approach then to detect those drones is to use a radar, because every drone has its propellers, and those propellers create a certain small chaos in the frequency band. So with a radar you can detect this. It's called the microdoppler. And with the microdoppler, you see a specific signature in the spectrum that's designated to a drone.
Okay, microdoppler, that just reminds me that we had the last episode covered with 5D, which we collaborate with at Rohde Schwarz. And they are experts in radar simulation software. And they have quite some information and quite some learnings to listen to about all things radar tech and radar simulation. So feel free to tune into the latest episode. We're coming closer to the collaboration with TRUMPF, which is a global laser expert in the field. Fill us in. How does that work? Why does it technologically make sense for Rohde Schwarz and TRUMPF to collaborate countering drones?
Because with the help of TRUMPF, we are developing a laser system and a counter-UAS system with an integrated laser. This is able to stop those dark drones. Because, as I mentioned earlier, an RF jammer, GPS jammer doesn't work on those dark drones. So we need a kind of effector that is able to stop those drones. And with a high-energy laser focused on a drone, the laser is able to stop the drone within 1 to 3 seconds. But also it's challenging for us to combine and integrate everything, because also a laser is dangerous. It's not an easy handheld device.
This is something I was thinking about. I mean, if the laser misses, what do you do then, or how do you prevent that?
Of course, those laser signals, when they shoot in the direction of a drone, we have to make sure that we actually match the drone. So we have a quite big security package and algorithm behind, with a lot of steps to make sure that we precisely follow the drone. To track the drone and to make the calculations within 4 microseconds to engage the drone and destroy the drone. But also we have to make sure that we mitigate the risk endangering other aircrafts, for example, or helicopters flying in this area, that we do not endanger them.
So I think we got this technological perspective on this collaboration. Thank you very much for sharing. We also had the opportunity to talk to our Executive Vice President of Technology Systems at Rohde Schwarz, Alexander Oriano, and he adds another perspective. So just listen to him next. total expertise in radio frequency tech. They have the total expertise in laser tech. It seems to be like a perfect match between Rohde and Schwarz and TRUMPF, European-based, even both in Germany. Deep vertical integration.
Right.
How does that kind of contribute to the future technology they are developing?
So maybe I can just start of how it was when we first came together. We traveled to Ditzingen, I remember very well, with my small team. We were 3 persons with me, and we felt like home. We have the same DNA, technology-driven on the one hand side, but also value-driven on the other hand side. And we would like to have this cooperation making a success.
But we're not doing it just this cooperation for the sake of it or for Rohde and Schwarz only because it's just cool innovation here. It's always for the benefit of customers. And why is that such a great advantage or move forward for them if we offer these new collaborative solutions in the future?
The RF radio frequency dark drones, today we do not offer a solution. But tomorrow, with our claim with TRUMPF together, we can counteract also those drones. So this is something that we are missing today. But we need to say, most of the drones are today still radio frequency controlled. So most of the drones we can counter already today, but we would like to close the gap to 100%. And you mentioned also the vertical integration. We offer a sovereign solution, which means not only that we are producing in Europe, but we are also having the production inside the company. That means if you are an engineer, normally you design something and you need then to see whether you can produce it. We can see it by just making demos, prototypes ourselves, and iterating with engineering to go to the edge of technology. Because if you think about the value chain of a counter drone, you need to first detect, then to classify, then to track, and to counteract. But as drones are getting more and more fast, you have very, very little time to counteract and to make an effect on those. And this time is something that you can only reduce if you have all those systems under your umbrella and iterating between them, such that you do not specify each of them individually, but you think about how to iterate between those teams engineering this super system. We have the potential to be much better than today's solutions.
So what you're referring to is, up until now, there is some kind of integrator company. As the nature of it is, has to be some kind of generalist.
Integrating the laser, then integrating the RF, direction finder, integrating the optoelectronics, and so on. This is not the best way to do it. When we had the first kickoff of the development teams, we clearly said, in the cooperation, we should not feel that we have 2 different entities. It should be one team. And whenever I go to those meetings where we see the team working, it's such a joy to see how good they are cooperating with each other, that I tend to say we would like to go back to engineering to join this team, because it's such a joy, it's such a pleasure, because they have such a good advancement and a good spirit by working together.
That sounds great. It's a bit like this curiosity-driven work with engineers, right?
Yeah.
They just match.
Absolutely.
Does that resonate with you, Ronnie? What is it that makes you fascinated, that makes you stay in this field and being happy about what comes next?
This area is a high-tech area. It's a fast-developing area, and I have the chance to work on solutions with professionals, with top-notch hardware and software, to protect the skies. And especially in the counter-drone area, the systems that we are developing, they are just there to protect lives.
Thanks, Ronnie, very much. And I promise you, next time I do a phone call or I will do my laundry, I will definitely think about you. Thanks very much for all these great insights.
Thank you for being here.
Thank you for joining, Ronny. Whoever might be interested in some more stuff to surf through all things spectrum, radio frequency spectrum, just check the show notes. We will definitely give you some more information there to learn even more about what we talked today. And we are very happy if you join us next time. So stay tuned.
And if you like this podcast, don't forget to subscribe, tell your friends, and tune in next time.